All right, imagine this, just for a second. You've finally done it. You've set up the digital twin.
That ultimate tech dream, right?
Exactly. And I'm not talking about some basic chat bot that can, write a limerick or set a timer for your pasta.
Oh, this is the real deal. The fully integrated open source personal assistant we've all been promised. It's got your Anthropic keys. It's in your Slack.
It's reading your WhatsApp, organizing that folder of private notes you've been putting off for, what, 5 years?
It is the ultimate productivity hack. I mean, it's what everyone in the productivity space is chasing right now. The ability to just clone your executive function.
Right. It's efficient. It's powerful. It feels like the future.
Yeah.
But now, imagine that while this digital twin is busy organizing your life, it didn't just leave the front door unlocked.
No.
It's more like it took the hinges off, installed a giant neon sign pointing inside, and invited the entire internet to come in and, well, become you.
And that is, uncomfortably, not a hypothetical. That's exactly what we're unpacking today. We are looking at a breaking situation involving Clawdbot.
Clawdbot. Yeah, but for anyone who isn't, scraping GitHub repos every weekend, this is a big deal in the AI agent space right now.
It's a surgeon gateway, is what it is. Think of it like the nervous system for your AI. It's the middleware that connects the brain, your big models like Claude 3.5 to the hands and eyes.
So Telegram, Signal, Discord, your local files, it's the glue.
It's the glue. And we've got a report here from Cybersecurity News dated just yesterday, January 26th, 2026.
From Guru Baran. And the findings are, honestly, they're startling. It turns out a simple configuration error, a really specific, almost boring oversight left hundreds of these agents exposed.
And we aren't just talking about leaked chat logs, though that's bad enough.
Yeah.
We're talking exposed API keys, credential theft, and this phrase the report uses, inherited agency.
Inherited agency. That phrase just gave me chills when I first read it. So the mission for this deep dive is to figure out exactly how this happened. How did over 900 smart, tech-savvy people accidentally broadcast their digital brains to the world?
And what does it tell us about that trade-off we're always making between frictionless convenience and actual security?
It's a classic story, isn't it? And it all starts with a security researcher, a guy named Jamieson O'Reilly.
Right, so let's get into the timeline. This is all very fresh. January 23rd, O'Reilly is on X, formerly Twitter, and he drops this thread that just lights up the security community.
And what's wild to me is that he wasn't doing some super complex pen test. He wasn't, cracking encryption in a dark room.
No, not at all. That's the scary part. He was basically just looking in the phone book. He was using Shodan.
Shodan is so fascinating. I always describe it to people as Google for things that shouldn't be on Google.
That's the perfect description. Google crawls websites. Shodan crawls devices. It just pings IP addresses across the world and asks, hey, what are you? A webcam, a server, a traffic light?
Or in this case, an AI agent gateway.
Exactly. O'Reilly decided to search for a very specific HTML title tag, Clawdbot control.
Just to see what was out there.
Yeah.
He was just curious about the footprint.
Yep.
And the results were loud. Shodan and another scanner, Sensi's, they just lit up.
Yeah.
Over 900 exposed gateways, most of them sitting on port 18789.
Okay, for context, 900 might not sound like a huge number if you're thinking about, say, a Facebook breach.
Right.
But for a specialized self-hosted developer tool, that has to be a massive percentage of the user base.
It's huge. It suggests a systemic problem, not just a few people making a mistake. And when we say exposed, we need to be really, really clear what that means.
This isn't a login page that was visible.
No.
Yeah.
We don't mean you could try to guess a password or brute force your way in.
Yeah.
We mean the door was wide open.
Completely unauthenticated.
You click the link in the Shodan result, and you're not greeted with the please log in prompt. You're just you're dropped straight into the control UI.
Okay, let's visualize that, because this is where it gets visceral. You click a random link on the internet, and suddenly you are sitting in the cockpit of someone else's AI. You're seeing their dashboard, their configuration, their entire conversation history, every private thought they typed into that prompt box, every question, every summary.
Wow. It's like walking up to an ATM and the person before you just left their session active.
But instead of just a bank account, it's a transcript of their brain.
And that Clawdbot control interface, it's the control plane. It's not just for viewing things. It handles the WebSockets. It executes tools.
So as an attacker, you're not just a voyeur, you're in the captain's chair.
You are. And that brings us to the billion-dollar question.
How?
How does this happen? These aren't novices. If you're setting up a self-hosted AI agent, You know your way around a terminal.
Right, you're not your grandma installing a browser toolbar. How do 900 plus people make the exact same catastrophic mistake?
This is where we get into the technical glitch. And I was looking at the code analysis on this.
Hmm?
It's a fascinating failure. It all hangs on this one concept.
Mm.
Localhost auto-approval.
Right, and it's a feature, not a bug, at least in theory. It's designed for developer happiness. When you're building this thing on your laptop, your local host,
Yeah.
you don't want to type in a password every single time you restart the server to test a change. It's friction.
So the software just has a rule. If the request comes from 127.0.1, the universal IP address for me, the system assumes it's safe. It says, oh, that's the owner, come on in.
Exactly. It's like a building security guard who's told, if someone walks directly out of the manager's office, just assume they're the manager.
That makes perfect sense for local development. But nobody just runs these on their laptop anymore. The whole point is to access it from your phone, from work.
Precisely. You want it everywhere. So users started setting up remote access, and the standard way to do that is with a reverse proxy. You put a server like Nginx or Caddy in front of the application.
Standard practice. The proxy handles the SSL certificate, the domain name, and it just passes the traffic along the app. It's like the receptionist at the front desk.
But here's the trap. Think about the path that data takes. The request comes from the internet, from the hacker. It hits the proxy. Then the proxy hands it off to Clawdbot. From Clawdbot's perspective, who is asking for access.
It sees the proxy.
And where does the proxy live?
On the same machine, usually. So 127.0.1.
Bingo. The request originates from the hacker, but by the time it touches the application, it's wearing a local host mask. The security guard sees the request coming from inside the building and just waves it through. Auto approval.
So it's a spoofing vulnerability by design.
Yeah.
But surely there's a way to tell the difference.
Proxies add headers, right? Like X forwarded for, to say, hey, this actually came from this other IP.
They do. And a secure app is supposed to check that header. But the code flaw here was in a default setting called gateway.trustedproxies. By default, that list was empty.
An empty list meant it just ignored the headers.
It ignored the forwarded information entirely. It just looked at the immediate handshake, saw the local proxy, and threw the gates wide open.
That is, wow. That is tragic. It's a road to hell is paved with good intentions kind of moment. People were trying to be sophisticated, setting up proxies, doing the right thing for security. And in doing so, they accidentally told the system to trust the entire internet. It just highlights this critical misunderstanding of where the security perimeter actually is.
The app thought the perimeter was the machine itself. The user thought it was the proxy. And in that gap, 900 people fell through.
Which brings us to what happens when you walk through that gap. We mentioned inherited agency earlier. This is where we move from a technical glitch to, well, nightmare fuel.
Right, because this is not just about reading data.
It's so much scarier than a standard data breach. Usually a breach is about confidentiality. Someone stole your password database or your emails.
Bad but passive. You change your passwords, you move on.
This is active. The report details that an attacker can dump all the environment variables. That means your Anthropic API keys, your OpenAI keys, oath secrets for Google.
So just financially, they could rack up a massive bill on my API accounts.
Easily. But that's the least of your problems. Because they have access to the control UI, they can use the AI's tools. If your agent can send emails, the attacker can send emails as you.
They're driving the car.
They are the car. And the most chilling part of the report, the part that really stood out, was the Signal integration.
Oh, I saw this. Signal's supposed to be the gold standard for privacy. End-to-end encrypted. How does this compromise Signal?
It doesn't break Signal's encryption. It bypasses the user completely. The exposure gives an attacker access to something called device linking URIs.
Okay, unpack that. What's that?
You know when you install Signal on your desktop and you have to scan that QR code on your phone to link them?
Yeah.
That QR code represents a URI, a unique link. Because the attacker has full access to the Clawdbot dashboard, they can just grab that linking URI, they can take that code and pair their device to your Signal account.
Wait a minute. If they link their device, that's persistent, isn't it?
Completely.
Yeah.
Even if you shut down the vulnerable server 5 minutes later, even if you patch it, their device is now a verified client on your Signal account. They see every message you send and receive in real time.
That's not a hack. That's an occupation. You would have to manually go into your Signal settings and audit your linked devices just to even know they were there.
Exactly. And honestly, how often do you do that?
Never. Literally never.
And it gets worse. The report mentions that some users were running Clawdbot in root containers.
Root being the God mode of computer permissions.
So if the container is running as root, the attacker gets access, they can execute arbitrary commands on the host machine. They don't just own the AI, they own the server it's running on. Total compromise.
This just drives home the danger of centralizing everything. We're building these agents to be these central hubs for our entire digital life.
We're creating a single point of failure. If I'm a hacker, why would I bother trying to phish your bank, then your email, then your Slack? If I can break into your AI agent, I get the keys to the whole kingdom in one go.
It's a one-stop shop for identity theft.
Yeah.
Okay, I'm thoroughly spooked. Let's talk triage. What's the fix? What do people need to do right now?
First step is immediate triage. The Clawdbot docs have been updated to recommend a specific command. Clawdbot security audit deep.
Clawdbot security audit in deep, and that just scans your config for this vulnerability.
Yeah, it does. But frankly, even if it comes back clean, you need to harden your configuration manually. You cannot trust the defaults anymore.
So what's the specific setting people need to change?
You have to go into your config file. First, set trusted proxies to 127 but 0.1. That forces the system to actually parse those X-forwarded for headers we talked about.
It tells Clawdbot to check the ID of the person the proxy is bringing in.
Exactly. And, of course, stop using auto-approval.
Right.
Enable password mode. Set gateway.auth.mode to password and define a Clawdbot gateway password.
It seems so obvious in hindsight. Just put a password on it.
It does. But there's a harsh reality here. If you run that audit and find you were exposed, just closing the hole is not enough.
Because of the persistence, the signal linking, the stolen keys.
Right. You have to assume you are completely burned, scorched earth. You have to rotate every single secret, new API keys, new Telegram tokens. And please go into Signal, go to linked devices, and just nuke anything you don't recognize.
That's a whole weekend of work right there.
It is, but it's necessary. The source also suggests a better architectural approach entirely, moving away from exposing ports with a reverse proxy.
Using tunnels instead, like Tailscale.
Yes, exactly. Tools like Tailscale Serve or Cloudflare tunnels. Your device isn't actually on the internet in the traditional sense. It's on a private overlay network.
So to even reach the application, you have to be authenticated to the private network first.
It moves the security layer completely outside the app. So even if the app has a bug, no one can get to it to exploit it. It's defense in depth.
I did notice one other detail in the report about versions. The latest release is 2026.1.14-.
Good catch. That was released January 15th. The security reports came out around the 26th.
Which means updating to the latest version doesn't actually fix this.
No, and that's a dangerous trap. You might do a Docker pull, think you're safe, and you're not. The fix is in the configuration, not just the software binary.
So don't rely on the update button. You have to get your hands dirty in the config files.
You have to. Run Clawdbot Doctor if you need help, but verify the settings yourself.
You know, taking a step back, this whole story feels like a watershed moment for this agentic AI era we're entering.
It really does. Clawdbot is just one example. There are dozens of these frameworks now, all racing to be the most capable, the most integrated.
But this highlights a fundamental tension. We all want ease of use. We want to install it and have it just work. But that is so often the enemy of security.
It is, and we're seeing the threat landscape shift. Attackers aren't just looking for servers anymore. They're looking for agency. They're looking for the tools that control the other tools.
It raises a really provocative question, I think. If an AI agent effectively is you digitally, if it speaks with your voice and acts with your authority, does securing it require a completely different mindset than just securing a server?
I think it has to. We treat servers like infrastructure. You know, cattle, not pets. But an AI agent, that's an extension of your mind. You wouldn't leave a photocopy of your passport taped to your front door. So why would you leave your AI agent on an open port without a password?
That is the thought I want to leave everyone with today. As you're building your digital second brain, just make sure you aren't giving away the keys to your first one.
Well put.
Thanks for diving deep with us. Stay safe out there. And seriously, go check those configurations.
Until next time.